The purpose of this lab is to determine the specific heat of a metal, and by doing that, identify what the metal is based on this one property. So you are going to get a metal cube that you do not know its identity, a calorimeter, which is essentially 2 coffee cups nested together, and a cardboard cover, a thermometer, and a beaker to boil water. You will start by boiling water in the beaker, and we want to get it boiling so that gas molecules, water vapor is leaving. At that point, we are going to put the unknown metal block into that boiling water. This is not to scale. And so we are going to let it sit there for a while. Okay. Then we are going to take 100 milliliters of cold water at about 10 degrees Celsius. It won't be exactly 10 degrees Celsius, and put it into the styrofoam cups. That is our calorimeter. Okay. If I continue on in the lab here, you will get the mass of your metal cube, and this metal cube this is an E, 0.2491 kilograms plus or minus 0.0001. Okay, I already said we're going to put the metal cube in the boiling water, and we are going to get its temperature after 6 minutes. So this metal cube has been heating in here, heating in this up here, and then after 6 minutes we are going to record the temperature of that metal cube. And I will tell you that the metal cube's initial temperature of the metal is 101.8 degrees Celsius. Now there's error within our measuring devices. There's different boiling temperatures at different elevations, and so to have it not exactly 100 is fine. Then we are going to take this metal cube from the hot boiling water with an assumed temperature of 101.8. If the boiling water is at 101.8 and the metal cube has been sitting in there for 6 minutes, we are going to assume that the metal cube has the same temperature. We are then going to transfer that into our calorimeter. The calorimeter has cool water in there, and the temperature of that cool water is 21.8 degrees Celsius. And so this metal cube is going to sit in here, transferring it very, very quickly so that we don't lose heat to the air as it moves, and then we are going to cover it with our cardboard cover as quickly as we can. So heat is transferred from hot to cold always. So hot metal cube to cold water, hot metal cube to cold water, and it keeps going and keeps transferring heat. And as it does that, the temperature of the water rises. The temperature of the water continues rising until it hits the highest temperature that it's going to. And then the temperature will start coming back down. The temperature is going to start coming back down because heat is escaping out of our system. So we want to record the highest temperature that the water in the calorimeter gets, and we will assume that the water and the block are both that temperature at that instant, and the highest temperature reached was 38.7 degrees Celsius. So with all of this information, you should be able to determine the specific heat capacity of the metal cube, and then using your book, you should be able to identify it, what it is made out of, based on the next or the closest specific heat capacity. One other thing I just want to point out is that it is important that you get exactly 100.0 milliliters of cold water, because if I know it's exactly 100 milliliters and the density of water is 1 gram per 1 milliliter, then I know 100 milliliters of water must be equal to 100 grams. So now you'll be able to answer the questions and complete the lab.